So this is what the graveyard shift is, apparently. Last one up. So thanks, Kate, for putting us on last. I was hoping that people would have gone away by now and just leave me and the sound man to switch the lights off and leave quietly, but here we are. So I'd like to talk about the Stirling-Dunblane-Alloa project. It's recent, it's relevant, particularly for the audience and the location of the venue that we're at. Not a particularly high-profile job, I have to say. It's not a high-speed main line. You'd probably call it a secondary line by high-speed line terminology, but nonetheless still a very important project in Scotland, which we had to deliver in a very challenging timescale. So we commenced in January 2016. Now, one thing that's worth mentioning, and I know a lot of the earlier speakers have talked about preparation time to do design and time spent doing survey work, all very, very important, of course. Because of the timescales on Stirling-Dunblane-Alloa, we had to have the line up and running by December 2018. There was a timetable change, 2018. And if anyone's travelled Edinburgh to Glasgow, they'll know the Class 170 DMUs that used to run the line. They were all part of a train franchise agreement, which meant they had to be cascaded down south. Paul will know that because he gets them into York from where you are. He used to get the old sprinters. So we were driven by rolling stock effectively being lost out of Scotland to go down south, and a new fleet of trains being constructed, the Class 385s. So on day one, we were up against it. We have no qualms about saying that. But one of the things that we were able to do was to start piling work without a fully signed off Form B. Now, some of you might, I haven't heard a sharp intake of breath, but I'm sure you're all thinking that is a risk. It's definitely a risk to designers, it's a risk to a project. But we felt confident that we could start piling work early on because we spent a lot of time up front on the outline design, on the Form A development. We got our layout plans up to a very high level, almost effectively Form B layout plans. So that was the big driver to start piling works early, and we did that on the Grangemouth branch. That was a bit sort of off-piste, if you like. We could work down there with longer times on site. So that was the big driver behind the project. It delivered 110 STK, around about 2,200 new structures. Those of you that travelled in Edinburgh to Glasgow, it's predominantly Series 2. We put in the two variants, high speed, heavy and light for the route. If you know the geography, it's right up the spine of Scotland, up the central belt. So it's the top of the triangle, effectively, between Edinburgh and Glasgow, around Carmew's Triangle, up through Larbert, Stirling, Dunblane, and then off to Alloa. And if anyone sort of remembers Kincardine Power Station, the coal trains that used to run there, obviously no longer now, but they travel from, or they used to travel from Stirling to Alloa, then along the line to Kincardine, and then, of course, on to the Fife Circle. So I'll just briefly go through these. So the geographical areas, we split them into four. You probably can't see from any place there, but if you know geographically, you've got Glasgow in the west, Edinburgh in the east, and then obviously the central belt runs from the bottom to the top. So section A was effectively from Greenhill Junction to Polmont at the right, and then the Grangemouth branch, and then up towards Larbert. Section B was Larbert up to and just slightly beyond Stirling, just north of Stirling was the end of section B. Section C was Stirling up to Dunblane, the end of the line as far as electrification was concerned. Another debate could be, why do we not just keep going to Perth? We were already there on site, we were already based at Cadder, had a full complement of project people, construction people. But as we've said on numerous occasions, we tend to fall off a cliff with workload. We sort of, it's all taps on or all taps off. Then section D was from Stirling up along the Kincardine lines to Alloa, which is the end of the service as far as we're concerned. It was a very, as far as we're concerned, it was a very traditional survey. So it was all boots on the ground. I know we've talked about LiDAR and RILAR. At the time we did the design, that wasn't available to us. So we did have to go out boots on the ground and physically walk the whole route and make sure that we picked up everything that we could see. We did point cloud surveys of Kippenross Tunnel. I'll show you the results of that shortly, because that was a particularly tight tunnel. And we obviously had to comply with standing clearance assessments at 7 stations. So we did point cloud surveys of all the canopies. So we knew exactly how much to take off the canopies, particularly what you call the dagger boards that hang over the platform. So our own survey team did all the the point cloud surveys. We set out all the foundations using GPS, so the traditional method of particularly wheels and tape measures and fibre tapes and steel tapes. We didn't use any of that. We used GPS coordinates, and then the final setting out was just the traditional steel tape or fibre tape from the running edge to the centre of the foundation. That's how we did all the setting out. So all of our designers, including myself, we physically walked the whole route, so we made sure that there was nothing missed off the top or survey that might, preclude an overland structure going in a certain location. So we physically walked it all out, and as we went, we also marked up all of the locations on the rail, just like we used to do traditionally, Peter. We used to go out and mark every location up, every half chord on the rails. We didn't quite do that, but marked up every foundation. Predominantly for doing trial holes, we had, as you can imagine, 2,200 trial holes to do. Maybe a debate for the medium and the long-term future. Is there a benefit in trial holes? Our Network Rail prepared to take the risk of going out and piling, but maybe having an S&T team on standby. So if we go through a cable, we've got the means to repair it before the position's handed back. That's obviously a debate for another day. What we did, innovation-wise, there wasn't really a lot, I have to say, but then because of the timescales we were under, we didn't have that luxury anyway. So what we did on the layout plans, we brought in a thing that we termed ourselves RECOS, critical structures. So RECOS, running edge, centre of steel. As designers, overland designers, we're all highly sensitive about the issue for signal obscurations. So we made sure that we didn't obscure any existing signals. There were no real new signals going in. There was a small number just north of Stirling, but generally it was an existing signalled route. But on the layout plans, we introduced this yellow box with a hazard warning triangle to say to the site teams who had layout plans with them, you are not allowed to reduce the RECOS because there's a danger you're going to obscure a signal. So that's a reminder to them on site. So rather than going out and sort of blindly padding away, these layout plans were all in their site packs, and they were told, it's okay to increase it slightly, that's fine, but do not reduce it, because with a lot of these, the fine sighting lines, they were very fine limits we had to work to. Excuse me. So we introduced that terminology. I'll move on. I've got far too many slides for the 20 minutes. But you can see on those boxes there at the very top and the very bottom, we used eastings, northings and Z coordinates for pile levels, all to a 3D grid, and all that information was passed to the piling contractor, so they were aware of all this information. TDC structures, they were all set out. If anyone that's done allocation design would know, they've got a knee brace. We try not to put SPS and stovepipes across the knee braces because you can't always secure them properly. So we always had a design rule, do not put a TTC in less than 3.4 metres, particularly on a pull-off, so you're pulling towards the structure, because there's a small risk that you won't be able to attach your standard Bonomi equipment onto the boom of the TTC. We designed it to a 2.81 CPOS value, continuous position of safety. So in the future, if Network Rail decide to put authorised walking routes along the side of the track, we should, in theory, have clearance to walk in front of every one of the new structures. So that was a standard design value to us. For the Bonomi frame as well, as you know, they have a limitation on reach. It's better than it used to be, but we still had limitations on the design. And then we always set out using the fibre tape and didn't rely on the OS coordinates, because then you're back into the issues you've got with signal obscurations. If you use an OS coordinate and it's 200 or 300 mil out, and you end up putting the pile 300 mil closer towards the track, that could be the difference between obscuring a signal and completely missing it. So that was just a rule we adopted. And I did hear earlier on, I don't know whether we can take the full credit for this, but when we did the Rutherglen and Court Bridge project, which a good friend and colleague Jim Watson at the back there was our client, there were a lot of piles that were just longer than 5.5 metres, and anyone that does allocation design will know that 5.5 metres used to be our standard allocated pile. When we did SDA, we had a lot of piles, 6-7 metres. Now, if you're going to install 7 metres of pile, anyone will know you've got to put the 2.5 metre section in the ground first, and then you add the longer section on top of that. So that takes time, it takes resources. There's a lot of piles get installed on embankments, steep embankments. You've got staff who try to stabilise themselves on a steep working surface area. So we did, we'll take the credit for it on this job, whether it was done before. We certainly never found any evidence. But we did check with the fabricators. They could do spiral welded piles up to 8 metres. We checked with the piling contractor. Yeah, we can lift up with a MOVAC. We can lift up 8 metres. And obviously the piling rig trailer, its own trailer, where you can put 6 piles, stack 6 piles up, they could still put 6 piles on the standard trailer. So we didn't have to do any major re-engineering. And you can imagine when we had maybe 25-30% of piles that were longer than 5.5 metres, that was a major saving. If anyone can maybe put me right when we do the questions later on, I haven't seen the 8-metre long pile in any basic design ranges yet. I've heard a rumour it's in Series 1, a rumour it's in UKMS, but I've yet to see it yet. But that's just a way of improving efficiency when you've got long piles to install in soft ground. So that's just a drawing that we did, just as a variation to the job. We've used it on subsequent schemes until it becomes available in the basic design range. And I know Anne talked earlier about, you know, redoing designs and re-engineering designs and repeating designs. To me, this should be in the basic design range now if it isn't already. So this is just something we developed for the scheme. That's just the component drawing. I'll quickly go through these. So that's just all the general piling information. There's nothing new about that you don't know about already. And just general installation information. And same about, you know, general tolerances. So we did a little handbook that we issued to the site teams to say, you know, when you're on site, you are allowed to make decisions. You don't have to keep coming back to the designer because you might lose time. Certainly we didn't raise TQs to keep going back and forward to designers. A lot of the staff were empowered to make these decisions by using these guidelines on site. So if they had a problem on site, they didn't just have to stop and move to the next structure. They were able to work it out for themselves using some basic rules. And of course, you can't apply that everywhere. Sometimes you have got to come back to an office and do a design change. But generally, that information allowed a lot of decisions to be made on site by the engineers. And same kind of information there. And again, and pretty much just sort of standard setting out information for piles above ground, so you've got enough room to work around the pile and make the connection onto the mast or a transfer plate. And same again with finished foundation levels, particularly on cuttings. So we needed to make sure that we survey, when we did our own topo survey, we surveyed shoulders of cuttings, obviously slopes of embankment, so we knew where the pile was going to be installed, what the profile of the ground was, so then we could allocate the finished foundation level for the pile and know exactly when the mast was bolted onto it. Masts weren't either, you know, let's say a metre too long, or worse than that, 500 metres too short. Sorry, 500 millimetres too short. Same point earlier about TDC structures with the recost value we adopted. And what we did in order to enable construction work to start early, we issued what we call an SFS. So with layout plans, we issued a steelwork foundation schedule, which was a schedule of piles. So the piles could be ordered, transfer plates could be ordered, everything could be ordered up front, but no actual cross-sections produced. Now, like you can imagine, if you want to start a project early and everyone's fully supportive of what you're doing, there's definitely an opportunity, armed with all the right information, to start work without your full AFC design pack. But that is obviously a shared risk. As we go maybe towards more self-assurance with Network Rail, this might be the way it's going to be. Maybe, you know, contractors will have to make these decisions more and more frequently, you know, in the best aim of a project, that we start early using schedules which have been fully checked, fully IDC'd, we're not cutting any corners, but allows early piling works to commence. And we've all seen those hazard warning triangles on layout plans. And again, so Stirling Station was a bit unique, a bit new. Category A listed. We weren't allowed to put big portal structures over the top. So what we did do, we used the Bonomi. Thanks, Rob. I've seen Rob somewhere. Is he still here? Anyway, for supplying what we needed from Fur and Frey. So Fur and Frey registrations. You might notice there, the structures were all painted navy blue. That was a council request for the structures to blend in a bit better. In order to get, if you like, a higher wire height through the stations, we cantilevered bridge arms off to the side so we could raise the wire height, improve the clearance, but also lift the wire height up as well so we could get 3.5 metres standing clearance. So we did that on quite a few footbridges. As you can see there, all the dagger boards were taken off and cut short because of clearance to pantographs. And then the final installation, what we came up with was the Fur and Frey arrangement, which, as you can see, is a pull-off and a push-off. Most importantly, particularly because Stirling Station's on a curve. So we needed a push-off arrangement as well, which would work with fairly low radial loads, but still work and be compliant. We had a low bridge to the North Shore Road, which caused a number of problems. You can see that was reconstructed to electrification clearances, but not to platform standard clearance values of 3.5 metres. So that presented a unique set of circumstances. Kipping Ross Tunnel, if anyone knows it, between Bridge of Allen and Dunblane. Quite an unusual tunnel. If you can see on the point cloud at the bottom, how it's been developed, you can see the steps in the profile of the tunnel of the brickwork. So from an electrification point of view, you can see that presents a number of issues. What we did was, if you can see halfway along the low step, we knew exactly how long it was, we knew what its position was. So we simply designed around it, so we didn't put any supports within that low point, we spanned around it. Now originally we were supposed to put the conductor beam system in, but that was put to one side. So we came up with a conventional tunnel cantilever arrangement, which allowed us to open up the span, so we weren't tied to 12 metres. We were able to put 40, 45 metre spans in, which allowed us to span across that low point. And then you can see the standard arrangement you've got there, which worked quite well all the way through the tunnel. Gave us all the clearances we want. So it gave us basic clearance all the way through. Fourth viaduct, we didn't have a lot of historical structures to get by. We had the fourth viaducts, which you can see there's an aerial shot there. Kincardine lines on, so that's looking towards Stirling Station. Kincardine lines on the left, the mains on the right. Because of the River Forth, and as we know now, there's a lot more rain falls out of the sky now. There's a lot more issues with flood risk. So as part of the design, if you can see that, we had to put in fenders, so you can see, when logs and trees disappear into the river and float downstream towards the sea, then, a lot of them do get wrapped around viaducts and piers and that kind of thing. So as a result of that, we did a design with our civils partners, MHB Consultants. We did a design that included a fender. So if a big log came washing down the river, and you could argue it would go downstream, but we had to put them on both sides of the pier. A fender was put on there just to deflect any logs away, so there was no risk at all from them striking the knee brace there. Malcolm's Yard, this was, you'll have all seen goalpost anchor structures. The likes of the Daventry containers come up from Daventry. Previously, they had to change traction at Moss End, put a diesel loco on, go up to Grangemouth, and then propel back in to the sidings that were obviously not wide at the time. But what we were asked to do is to part-electrify the 4 sidings within the site. So we used the standard Virendale portal. And you can see there the structure on the left with a container wagon underneath. So from the right to the left, you've got 4 tramway equipment that terminate on that boom. And the train comes into the loop. It propels in with now the electric locomotive. Stops obviously short of the anchor structure. And then they split the train, so half the train is split. The locomotive goes off, it then shunts it into the next siding. So you've now got 2 half trains you can use. And then, sorry, I didn't realise there's a time counter on the front there. That's interesting, thank you. It's good. So that's how it works now. And then they use these if you've ever seen these reach stackers, which can reach over one container to get the next one. And as a result of that, we partly electrified those 4 sidings using 4 partly wired roads. And one of our colleagues today mentioned about incremental improvements. That's an incremental improvement. It was only to electrify maybe 6 SDK, but it saves having to have diesel traction at Moss End Yard specifically just for this movement. Now, obviously, diesel traction will still be there for other trips, but this now means electric traction can run all the way from Daventry, all the way to Grangemouth, and all the way back again. So they might have to change train crews, but they don't have to change traction. So that's what we developed for the yard. That's pretty much it. So thank you very much.